Good afternoon, guys. Welcome to Module 5. In this session, we are covering two critical aspects of development. First, we'll explore the cloud part of Find My File, the secure backend services that handle users' account and payments. Then we will dive into one of the most important but often overlooked topics, the real world debugging journey. Let's look at the agenda. The agenda for today's session: in the backend services section, we will cover our serverless toolkit. Second, we'll cover Firebase, Firestore, and Cloud Functions. Then we'll cover the securely handling of API keys. And in the debugging section, we will cover the problem of dependency hell. Then we will cover becoming a detective and solving those problems. And then we will cover the environmental problems and what we did to overcome it. And then, as always, we will summarize this session and discuss the content for next session. So let's move on to the backend services. Our serverless toolkit. Let's look at it. To build our backend without managing physical servers, we use a serverless approach. Our toolkit consists of Firebase authentication for logins. It consists of Cloud Firestore for our databases. It contains Cloud Functions for our server-side code and Razorpay for payments. This allows us to focus on features and not infrastructures. So let's look at Firebase, Firestore, and Cloud Functions. Firebase is the core of our backend. We use authentication for secure logins. We use Firestore as our source of truth for storing user subscription data and so on. And we use Cloud Functions as our server brains. This is where our critical security logic lives, like our verify Razorpay payment function, which confirms a payment directly with Razorpay's server before updating a user's subscription in our database, which is Firestore. Now let's look at index.js file, which brings all of this together. So it connects the three layers which are part of the application to the backend services layer. Our index.js file defines three main functions. First is to create Razorpay order. This is called by the application to securely start a payment by creating an official order with Razorpay. This code has been shown in the screen, while the next two codes, which are not here on the screen, are one to verify Razorpay payment. This is our most critical security function. It is called after the user pays. It double checks with Razorpay server to confirm the payment is real and successful before updating the user subscription in our database. And the third, request account deletion. This function is called from the settings screen of our UI, and it securely adds a user to a deletion queue in our Firestore database, which then a batch function is run on a daily basis to remove it. Now let's look at how we secure all of this. The most critical part of application security is to handle API keys in a secure manner. Every single one of our cloud functions begin with this critical check, which you could have checked in the previous screen. If, and within parentheses, you have request.auth, AUTH. When our app calls a function, the Firebase SDK automatically attaches the user's login token. This check on the server verifies that the token is valid and the call is coming from a legitimate signed in user. If not, the function immediately stops. This is the first line of defense that prevents unauthorized access. A critical rule is to never store secret API keys in our mobile app. We solve this using Google's Secret Manager. We store our sensitive Razorpay's keys in this secure vault, and only our cloud functions have permission to access them. This ensures our app is secure and our keys are never exposed. Therefore, the Razorpay key secret is not stored in the index.js file, and this is very common practice not to store anything in index.js file. This is a critical security measure. We use a much more secure method. One is to store in vault. We store the secret key in secure encrypted vault called Google's Secret Manager. Second is grant permission. We give our cloud function special permission to access this vault. And third is load at runtime. When the function runs, it securely reads the key from the vault into the environment variable, which is process.env razorpay key secret. The key only exists in memory for a brief moment till the time the function is running. This process ensures that our secret key is never written down in our code, never saved in our Git repository, and is never exposed to public, which is the professional standard for handling sensitive API key. And you should practice this in all your application development. So let's look at our debugging journey and let's understand the dependency problem that we face. Our first attempt to build the application failed completely because the logs showed a could not resolve error for a key TensorFlow library that we initially wanted to use. The library had been deprecated and removed from the central repository. The code didn't even have a chance to run. This is where instead of just trying to solve the code problem, you have to go beyond the trying to solve the code problem into detective mode where you go and manually check the TensorFlow repository or Maven Central repository, wherever you're downloading it from, and see where the problem is. Now, we discovered through the version history in Maven Central repository that it was no longer maintained and we needed to find an alternative. This led to a key architectural decision. Instead of a low level TensorFlow library, we pivoted to Google's high level ML kit. We specifically choose the unbundled version. This keeps our initial app download size very small. The trade off is that the AI model is downloadable by Google Play services on the first use, but it's a great strategy for keeping an app lightweight. The core functionality of the app, reading text from images, would have been the same with either of these library, but the complexity and the user experience would have been very different. So think of it like building a car. The original plan that we had of using a low level TensorFlow light library, this approach is like being given a powerful car engine. It's the core component, but it's just the engine. The developer's job then becomes with this library, we would have been responsible for building the rest of the car ourselves. For example, pre-processing. You have to manually write the code to take an image from the user's phone, resize it, and convert it into exact numerical format the AI model expects. Inference, that would be another thing you have to solve, writing the low level code to feed this data into the model. Then post processing, the model would give us back a complex raw output like list of numbers representing characters and their position. We would then have to write more code to interpret these numbers and assemble them back into readable words and sentences. The downside, this is very complex, time consuming, and error prone process. A single mistake in the pre processing or post processing code will make the entire feature fail. The second solution, which is the final solution, this is like being given a completely ready to drive car. It's not just the engine, it's the engine and chassis and steering wheel and the dashboard, everything pre built and working together. Our job became incredibly simple. The ML kit library handles all the complex steps internally. We just have to give an image to ML kit, receive a clean, simple string of text back. And the upside is it's much faster than the previous mode, faster to implement, more reliable, and less prone to bugs. So now we were able to focus on our app's feature inside of the low level complexities of the AI model. In summary, both libraries achieve the same goal, but MLKit is a high level done for you solution that saved us a huge amount of developmental time and the complexity. Let's look at the environment problem, the silent failure. Our code was perfect, our dependencies were correct, but the build still failed with unresolved reference errors. The errors pointed to our code, but the problem wasn't in the code at all. It was in the build environment. The clue came from the error unable to delete directory. This pointed to a file lock issue, a common problem on Windows, where a background process can prevent the build system from cleaning up old files. Even after fixing that, some dependencies still wouldn't download correctly. The final critical discovery was the file permission, where the root was the root cause. The Gradle build system running as a normal user did not allow the operating system from writing the downloaded libraries into its cache. And this happened because the Android Studio was shut down or restarted. And when you restart it, it comes back as a normal user, not as a administrator. So when we ran it again as administrator, the issue was resolved. And the crucial problem of trying to find issues in your code is not always the solution. Sometimes it is the third parties, sometimes it is the environment, sometimes the things you're trying to download doesn't exist. So all these things need to be checked and rechecked. Now let's summarize. In this module, we covered both the cloud-based services that power the app and the real-world debugging challenges we face to make them work. So what we covered under cloud-based services, we explored our serverless toolkit, including Firebase authentication for secure logins, Cloud Firestore for storing subscription data, and Cloud Functions for running our critical server-side logic, like verifying payments. And then we looked at security best practices. We learned why you should never store API keys in your application and how we use Google's secret manager to keep our Razorpay keys safe. Then we looked at the real-world problems like dependency hell and the environmental problems. In the next session, which will be the final session, we'll discuss about polishing the application and publishing. We'll discuss the final debugging story. We'll analyze the critical unauthenticated error that only appears in the release builds and learn why both debug and release SHA1 keys must be registered in Firebase. We'll see how to generate a signed app bundle. We'll walk through the process. We'll look at the key store. We'll cover the absolute importance of safely backing up your key store file, which is your unrecoverable master key to your application. And then we'll look at the Google Play console. We do a high level tour of the publishing checklist, including the mandatory policy questionnaires like content rating and the data safety section. And then submitting for review on Google Play Store. Finally, we'll cover the process of submitting the application, how to do a close test, and preparing for the final production rollout. So thank you all for joining. We will see you in the next session.